What's up, everybody? Welcome to Arroyo Office Hours, episode 134, your one-stop shop for cannabis cultivation education. I'm your moderator, Cian. I'm joined by our resident cultivation experts, Jason and Seth, in the studio today. How's it going, guys?
Good, man.
And then we have a special guest for the day, Willy Stober Sorry, that just keeps rolling off the tongue like that, Willy. Sorry. Willy Stober from Stober Engineering. How are you doing today, Willy?
Great to be here.
Fantastic. Well, I think let's start out, Willy, by having you introduce yourself and tell us a little bit about who you are and where you're from.
Yeah. My name is Willy Stober. I'm from Sonoma County in California, which is about an hour north of San Francisco. My background's in mechanical engineering. I'm a PE out here in California, and I have been sort of traditionally in my career involved in building energy and thermal loads sort of analysis to support design and research for code regulations and whatnot. And then about, I guess it's been like 3 years or so ago, I got the opportunity to get involved in a PG&E-funded study to kind of understand indoor cannabis cultivation, energy use, and thermal loads so that the state can be better about knowing how to fairly and most effectively regulate it or put in standards to help consumers. And so I spent about 2 years sort of heavily studying a facility that had Arroyo on it. I'd say out of that, I learned a ton because it was funded by the state, so we got an opportunity to look into a lot of things that people probably wouldn't have paid us to do otherwise. So got a lot of good opportunity to look really deeply into the thermal loads, evapotranspiration, and how HVAC systems should be designed to most effectively and efficiently satisfy those conditions. And I also, I got to know the owner pretty well where we were studying, and asked him if I could do some more work for him, just like on my own. And so I've been doing that for the past year or two, and just gone more deeply into other things and to still kind of centered around HVAC and environment. But, I've also had the opportunity to look at all their harvest yields and compare the environments of different harvest success and try to find some patterns around environment and, soil moisture percentages and EC as reported by Arroyo. And I gotten a pretty, I would say, well-rounded view on the connection of HVAC and growing.
That's awesome. It's a really important area of study that you're looking at, and it's going to become more and more important as energy becomes more expensive, and it's going to become more regulated in our industry without a doubt. And I mean, I just had a conversation with someone today that the whole thing centered around how he's managing thermal loads in his facility and how much energy or money he's spending in energy costs trying to manage that. So it's a really relevant topic for sure.
Yeah, because there's the direct, energy costs from the owners. But I would say even more impactful is that I don't know if the science is 100% defined yet, but the ability to precisely and I would say kind of provide a stable environment can lead to substantial yield improvements. Or the other way to look at it is if you're not controlling your environment and you expose your plants to drastic fluctuations, you can risk drastic harvest failures. And if you look at that over the course of a year, that could be, hundreds of thousands of dollars for like a 5,000 square foot flower room. So, the direct energy cost and then just the maintenance of your good yield numbers as HVAC can be very impactful.
Absolutely. And I think one thing, Willie, that I'd like to get into a little bit with you is how difficult it is to scale up some of these systems, because when we talk about blowing up any kind of action to a whole room, switching lights on and off, turning equipment on and off becomes really difficult to manage, because now you're hitting a point where you're maxing out your sensible load. You don't have anything left in the event that you're going to go have an extreme outside weather event or something like that requires more interior power pull to deal with. And I think that's something that's one area you've really delved into. What are some of the big challenges you find as people try to go above? You mentioned the 5,000 square foot, but what happens when we hit like 15, 20 in terms of trying to balance all this equipment?
Yeah, I would say and I'm speaking just from, stories I've heard, because I personally haven't been a grower, but I just know, before everything was legalized, when people were doing it on a smaller scale, they were using kind of the decoupled model with standalones and split systems. And, maybe they could open a window here or there to kind of equalize the environments. But once you start scaling up, now you've entered the realm where you need commercial equipment. And with commercial equipment comes increased complexity of operation. So some of the challenges is now, as a grower, not only do you have to know the science and botany of growing, but now you have to try to understand the physics of how my air conditioner is operating, because not only is it a commercial piece of equipment, but it's a piece of equipment that should be operating at ranges that normal commercial, office commercial equipment is not really operating. It's got to satisfy a lot of sensible load and low latent loads early in the growth cycle, and then be able to switch towards the middle and ends of the growth cycle to high latent load, low sensible load. It's got to do lights on and lights off, throughout the day. It's got to treat the environment as the plant is fluctuating its evapotranspiration. So I would say that's maybe one of the biggest challenges, is if you're a grower and you don't have the expertise on your staff, because this stuff is even hard for an engineer. So a grower, it's kind of a tough. Did I cut out for a sec? I just got a call.
Yeah, you're good.
You guys hear me? You guys hear me fine?
Yep.
Okay. So as a grower, it's like you're not only are you trying to understand the physics of air conditioning, but you have to understand it on maybe its most complicated application. And on top of that, I don't know. I don't have I don't know every manufacturer, but some of the manufacturers don't quite understand what these units need to be capable of doing. So at least in my experience, the challenge has kind of been this interdisciplinary knowledge required to not only know growing and botany, but what should my piece of equipment be doing, and what is it doing right now, and is that right or is that wrong? Because you could have the best design system in the world, but if it's doing something weird, then it's no good. So yeah, that answer your question?
Yeah, I think so.
Yeah, and to add to that complexity, I mean, we've got two things that have always challenged me when trying to help people do HVAC stuff. And first off is genetic preference, right? You can't just do the math and say, this is going to be the perfect environment, right? Sometimes that answer of whether you're doing a great job or not on programming that stuff is, did the end result give me better quality and better quantity of that strain, and obviously taking documentation of that as well. And then another one, I know the site that you've worked on, that I've worked with you a little bit, doesn't necessarily have copy paste rooms. Copy paste rooms are what I consider when you have you have brand new build out, and all of the hopefully dimensions are very similar. HVAC equipment is the same.
Right.
What are your steps as far as starting to work with those non-copy pastes when you've got rooms that have different numbers of HVAC units or different types and capacities?
So from the study, we've sort of defined, what are the important internal loads to characterize in these spaces. And as you could probably guess, it's, the lights, the plants, and the fans. So one of the outputs of the study was to try to kind of derive like a theoretical load that the room should have been giving off had it been given the proper environment, which was challenging because in these spaces, and I'm sure in a lot of other facilities, they're not really achieving what their goal is. So if you just study the empirical data, you're not really seeing what it could have been. So that was kind of the goal of the study, was to kind of be, okay, if this room was given the best environment, what would it have, its evapotranspiration rate would have been? And the way we did that was kind of piece together like the really good days throughout all the cycles that we captured. So with that theoretical evapotranspiration load, with your lighting load and fan loads, and then the third, maybe most critical thing is, what are your temperature set point goals and relative humidity, basically your VPD and temperature, because those significantly affect like the physics of what your unit can do. So if we're looking at like an existing room that already has equipment, then you have what your capabilities are kind of restricted or defined. So at that point, it's about understanding, what can my piece of equipment do exactly? And how do I manipulate my room in order to exist in a range that my piece of equipment can satisfy? So that might be like reducing the number of plants, taking out some lights, or switching the type of lights to change the heat, and then changing set points. So maybe I really want that 7450 at the end of the grow cycle, but do I ever achieve it? And I don't know, maybe not. So maybe what's more important is that I provide a stable environment where I'm not necessarily hitting those ideal set points, but I'm not presenting a situation where my piece of equipment's struggling and maybe doing weird things. I'm giving it something it can handle. And in that way, you're not getting like the exact temperatures you want, but you're getting a more stable environment, which I would say is probably the better trade-off. So I guess in summary, it's like, if I have my piece of equipment defined, how do I manipulate my room, the lights, plants, and set point to meet what it can do?
I think that's a really interesting way of looking at it, because I think a lot of people traditionally try to think about like, what equipment do I need to be able to make this room perform? Not so much how do I manipulate my room to make my equipment perform the best. And I think that's a really unique perspective to look at managing your HVAC systems with, because it is going to allow you to ideally make the most use of what you have, right? And that's something I love talking to people about all the time is, not necessarily going down the road of making massive changes, but how do you get the most bang for your buck out of what you've already got going right now?
Exactly. And it's like, sorry, go ahead.
Oh, sorry. Well, I just wanted to build on what Cian said and say there's a huge part of all this that I think gets lost because there's so much technology right now being thrown at cannabis growers. Like in terms of agriculture, we're the ripest market to throw new things at, right? Like, hey, try a subsonic vibrator for your plants. We could go down all kinds of weird rabbit holes that like those things have no traction in greater ag, but they're trying to compete in the cannabis space because there seems to be more money to spend on things like that. But the reality for the growers is exactly what you're talking about. What can you do with what you have and finding out where those realistic limits are? Because if you're operating in a facility that's under spec, the strategy to fix that might cost a lot more than you can afford. And there might actually be practical fixes. Like you said, pull some plants out of a room, change up your lighting, start trying to do some ROI benefit analysis on, okay, if I buy that new Dehu, is that can actually get me where I need to go? Start doing some math on this.
Yeah. And one thing like that in my experience, because I've come from a non-grower's background, and one thing that I've noticed in this industry is that like, the metric of success is that lots of people use different metrics. Like they'll say pounds per light or pounds per canopy square foot or what pounds per plant or whatever. And to me, it's all about pounds per square foot of that room. Because at the end of the day, as a grower, it's like, I have a certain square footage allotted to me and maybe an existing piece of mechanical equipment. How do I get the most pounds per square foot out of that space, whether that's 80 plants per table or 50 plants per table, whether that's 50 lights or 100 lights. So it's like, to me, that's the simplest way to put it, and kind of speaks to the ROI process that you're speaking of, is that you need to have like a very defined metric as your goal to start to do these manipulations, because it's, it can be non-intuitive. Like at the facility I'm studying, they were using like 120 plants per table for the longest time. And then I think they had like some sort of mistake with the cloning, where now they had to do 80 plants per table. And then it just so happened that was like one of their best, on an absolute basis, one of their best harvests. So they're like, oh, like, I think that there's something to that. So their per plant was like way higher. And then their absolute and A buds and everything was higher. And so their dollars per square foot was absolutely higher with less plants. So it's just an example of how there's so many parameters and variables. And so like, to just kind of have one metric as a beacon of success, I think is useful.
Some of the work I've done with you it's kind of one of the reasons I absolutely love kind of the systems we've built here. And really what it comes down to is, for me being a grower and a slightly technical person, I might even be somewhat technical, but more than slightly, we're thinking about the theoretical and then the implementation side, right? Obviously the engineering side, like you said, you start off with the theoretical, and then the implementation side is, just a grower getting it done. And you've done a really great job bridging the gap there with the people that we're working with in Sacramento and you are working with. And I guess for me, it's really, really cool because the system where we're capturing enough data that you guys can realistically build models out that end up in better implementation. It's just so fun to see that biology and that physics get tied together.
Yeah. And I was lucky to be exposed to a facility that, already had Arroyo, because now I'm getting more into the industry, and I'm meeting some growers that are, not using it or even like hand watering, and so I'm like, oh, that wasn't like a typical thing, because the data is invaluable if you know how to use it, because you can very clearly see connections of certain things that allow you to put value on stable HVAC control. Like, for example, one of the things that we noticed was that if we were looking at the daily drybacks over the course of a bunch of grow cycles, and we saw some grow cycles where like the HVAC failed at night for some reason. So it got really cold for like 3 or 4 days before it was fixed. But what that did is it like permanently affected the drybacks of the plant. So it couldn't achieve like the high, I forget what the percentages were, but like 20 or 30% drybacks that in the most successful harvests you were seeing. So you can see that as you're speaking, that like connection to the biology. And and I agree. That's why I love working in this space, because it's like super, super interesting and like satisfying to like see these patterns and actually see things that keep showing up and things that really confuse people. And because there's just so many parameters, and once you can isolate and see what it is that's actually happening, it's very satisfying.
Definitely. I'm kind of curious because you were talking about how it's a little counterintuitive sometimes, the types of optimal decisions that end up coming, or the optimal results that you end up with in terms of decisions you're making with these control systems or your HVAC implementation. And is there anything, it sounds like it at least, that maybe came out during your research that really surprised you, that you maybe had different conception of how that was going to look going into it?
Yeah, I mean, one example pops in my head that I've actually come to realize recently, and I should say this with a caveat, is that this is like very recent work. So needs to be vetted out a little bit more. But in the process of doing this study, I've come to, without any ties to manufacturers or anything, I've just come to realize that an integrated system, which does the cooling and dehumidification in one system versus a decoupled, is the better way to go, which kind of puts you at odds with the standalone dehumidifier market. But what I've studied sort of recently as a part of code work is that they're actually standalone dehumidifiers can, in that if when you really are trying to hit that cold and dry environment in the last 2 weeks, even though the standalone dehumidifiers are giving off heat during the lights on space, which you would think would raise the load of your rooftop unit, you actually can reduce, not insignificantly, like by a decent amount, the total tonnage required of your rooftop unit if you utilize standalones during the last 2 weeks, just because it changes the characters of the what we call the sensible heat ratio, which is basically the ratio of dry heat to wet heat that ends up at the unit. And essentially, even though the total load is higher going to the unit, it's a condition that's much more efficient for the unit to satisfy. So the balance actually lowers the total tonnage of that unit. So that's something that was kind of non-intuitive to me, because it gives off more heat. There's more load in the space, but the compressor's tonnage is actually dictated by not only just the load, but what condition of air it's seeing to remove that load from, if that makes sense. And it's kind of, without going into all the details, because it's kind of can start to get complicated, the psychometrics of it, but that's kind of been an example of maybe the more impactful thing to realize in these spaces, that you're, and I know this has been spoken of a lot, but your set point, the room air conditions are very significant in understanding what your units can do and the conditions that are there, if that makes sense.
Absolutely does. And I follow that. It would absolutely have surprised me to realize that that's going to allow you to have a lower tonnage capacity on your rooftop unit, just employing those in those last few weeks. I mean, I've always personally felt that like employing units those last few weeks is a great way to supplement existing infrastructure. For example, if you don't have the capacity to be able to pull more out of the room with your rooftop units, but I would have never guessed that it actually helped make a smaller capacity or a smaller tonnage unit more applicable in that space.
Yeah, and again, with the caveat that this needs to be looked into more, and I would say there's it depends, but I think normally it's, if you're trying to go for that really cold and dry, then that's usually the case. But there's some cases where that doesn't pan out. So it would have to be looked at on a case by case basis. But there are for sure cases where, well, I don't want to say for sure, but there's cases where that is true. And I know, I'm not the first one to think of that. I studied it because there was another engineer who said that that's what he does on projects, because it basically, if you're designing a room from scratch and you're looking at this type of system you need to buy and the ductwork and all that, you can reduce the size of the coils and the fans and everything if you implement, or this is what he says, if you implement standalone dehumidifiers in the last 2 weeks, only that, because they don't really make sense in the other parts of the cycle. But just the last 2 weeks, lights on, you can actually reduce, the size of that unit and the subsequent, theoretically, the infrastructure to support that equipment as well. So you might end up, with a lower cost system. That's what he does. And that's kind of why they had me look into it. And at least theoretically at this point, I see what he's saying.
I think that's where some of this gets really interesting, because we're dealing with different equipment types that operate with different levels of efficiency in certain ranges. And if you were to look at a lot of this on a base level, like, okay, face level, I'm plugging all these machines in. Each one is supposed to provide me with a certain amount of capacity. Okay, face value from the manufacturer, that capacity rating is at a certain temperature condition. Now that I've shifted it to a different temperature, different humidity condition, I'm probably going to have a learning curve on, okay, how does this machine actually react to those set points in this given space? And then what am I looking to optimize? It's, especially when you get outside environment involved, that gets really interesting. I've worked with a lot of people in like Arizona, particularly. That's a fun example where they have the exact same problems or exact opposite problems, as Sonoma County has, for instance. Like, they don't have fog ever. They don't have humid nights, totally different. So like, how you're going to manipulate your AC versus your dehus to maintain a certain amount of heat and humidity totally changes. And I think that's one thing that it's good to know about going into it, but you're going to learn it one way or the other, trying to operate any of these systems. And then moving past, once you've understood, like, hey, I've got some different set point manipulation I've got to do with my different systems that are decoupled, it makes sense for a lot of things to be working in unison. I can take my AC off of not only temp, but humidity. Now I've got a few more metrics to play with and a few more variables. However, I think the frustrating part for a lot of growers is there's just no real, everything we talk about on this show, and I'm sure you've talked about, just like you mentioned, like, hey, this, I can't say the science is 100% there yet on this. There's always a but. There's always a caveat where it's like, hey, man, if 10 out of 10 things aren't in place, that last 11th piece isn't going to do anything for you. And that's really difficult to balance when you've got all these variables and so much information out there flying at you that's saying, hey, here's an easy fix. Well, a lot of easy fixes were lucky. That's kind of how it turns out.
Totally. Or they worked in the summer and then they don't work in the winter. And I would say one thing that I'm really interested in getting involved more in is the integration of all the systems in a facility. Like if you have a Roya, if you have different air conditioning units, and integrating all that data to one platform so that you can better understand all of these variables and how they interact with each other and why certain things work and why they don't, so that you can gradually get to the point where you actually truly understand what's going on. Because I think without the data, the human brain just isn't capable of cataloging all these things and seeing. I think humans are very good at seeing patterns, but we're not, when it starts to get above a certain scale, like 10, 20, 30 different variables for one room, it's impossible. So you need a computer, a system to catalog all this stuff and a way to look at it all. Because I would say my personal philosophy, like speaking towards your point about like, okay, we can design it a certain way, but if this isn't right, then it's going to not operate properly. I think the better way to design is like you do the due diligence to characterize all the loads, but you give yourself some wiggle room with the understanding that you will have a system implemented to monitor and understand what's happening. And then you'll have the ability to recalibrate, to change it and get it dialed in. I think having this concept of like, it's going to be perfect from the get-go does a disservice to the design process as a whole. If you're more like, okay, we're going to get it 80% of the way there, and then we're going to also implement a system to monitor it very carefully, and then have the ability to change things up, or the understanding of my equipment, so I know what needs to be changed. I think that's the better way, or a way to do things. So that makes sense to me.
Yeah, it's coming together, I would say, in the space. Part of it I think that's tough is, when you get outside of cannabis and controlled ag, there's just not as much money out there to really put towards developing some of these more cohesive systems. So yeah, that's where expertise has to come in and help us identify where we need to be making some of these changes and how you actually work with a particular, I'm not going to say system, because most facilities have a set of systems that you're now, not just you, but any grower is the link between, hey, I've got 4 different systems trying to operate in unison. I've got to figure this out. It's similar to, maybe learning how to play an instrument. Yeah. Except without good directions. You can't go buy a really good book to tell you what the notes are. You kind of got to like pluck a string and listen and see if it sounds good.
Yeah, I like that. It's a good analogy.
I like to talk to people about that all the time. I tell people, I use the phrase institutionalized knowledge, where, if you have someone that has spent a lot of time designing, building out, and operating a facility, they're going to have a lot more intimate knowledge of the right chords to pluck in that analogy, right? To be able to produce the result that they're looking for than someone who's walking in fresh from a theoretical perspective, where they understand set points, but they don't necessarily know how all the combined systems in that specific space are going to work in concert to help them achieve that goal.
Yeah, 100%. Yeah, I think I was speaking to earlier, right? This space is special in that in order to be effective, it requires a lot of interdisciplinary knowledge of what they're trying to do, the growers are trying to do, and also what these HVAC units are trying to do. And because if you have one without the other, you could be missing a lot. Like that's kind of how I was when I started this study. There was a ton of things when I remember because we had all the sensors and stuff installed, and then I got like the first month's worth of data. And I went through it, and these guys were having issues with their climate control. And I was like, oh, this is the reason why, and this is what's happening. And okay, we got to figure it out. And then 2 months later, I look at the next batch of data, and I'm like, this is like completely different. Like, and I didn't even understand the concept of evapotranspiration. I understood what it was, but I didn't really understand how much it varied. So it's like, if you're without that knowledge, you can be completely befuddled by, you understand HVAC and all that stuff. You're like, what in the hell is going on? So yeah, I completely agree to have that, facility experience to sort of feel out all these unique different situations of these facilities with different types of units in one room, and you kind of got to feel it out.
Well, one thing I just interrupt for a second, Jason, because I think Willy can really comment to this. Coming from the outside the cannabis, like indoor growing community specifically, when you started to come in and study some of these facilities, the HVAC setups, efficiencies, did you ever go look for, historical literature and knowledge on greenhouse operation and indoor growing operation? Because I like to say that because that's my background, and coming into cannabis, my mind has been blown because we've been able to push it in ways that like people just literally had never studied 15, 20 years ago.
Totally. Yeah. There's not a lot on cannabis that exists, but I did do a lot of other research. I can't remember exactly what I think I just basically looked at all there was on cannabis specifically, but also read some stuff on like tomatoes and whatnot. There was this study or this procedure that was super interesting. I don't remember what the paper was or who did it, but they had, they've had whatever, thousands of grow cycles at this point to study. So they had made like a matrix of environmental conditions and harvest success, so they could see precisely, what environments lead to the best results, and like how much do I need to push it? Because maybe if I'm keeping things at like 75, 60, I'm getting a great harvest. But if I bump it up to 80, 70, I get a little worse harvest. But now my sort systems are much less complicated and easier to maintain. Than they had done something like that, which I think the cannabis industry, I'm sure there's people who've got it dialed in, like these big growers and operators. But I would say as an industry that there isn't a lot of literature out there that sort of speaks to the exact conditions that are required. I don't know, you guys would know better than me, but like, I would say it's kind of like somebody's secret sauce at this point.
Well, I'll say
like the temperature set point stays.
Yeah. Well, that, and then just simple things like Jason and I worked in the same greenhouse. The evolution of that, there's another greenhouse build out, similar plans. Guess what? The next one had better ventilation. Why? Because the first build out was built on a system that was, hey, this company had been building greenhouses that you could use for, like my background, plant breeding and research. we just never push the demand nearly as high as cannabis growers are capable of, because we got a crop that's actually worth it to push that. So when you started, when I started looking at, evapotranspiration rates and dehu requirements for different rooms, it's like, holy crap, we can actually keep pumping this, guys. The more energy we put into this system, everything has to increase to a level that, surprises anyone who's dealt with like traditional regular ag greenhouse development and indoor grow facilities. And outside of cannabis, let's face it, how many crops were grown indoors under artificial light?
Yeah.
Like, very few,
right.
And if so, like how many, you got your Gotham's greens types out there, but over the last 20 years, all the concepts in regular ag for like microgreens production or indoor vegetable production, it has to be very circumstantial for that to actually work out economically.
Totally.
Like if we're talking about the US, like, we're in Eastern Washington here. Could we have a lot of vegetable greenhouses here? Sure. But we're gonna have to burn natural gas to keep them warm. There's gonna be energy input costs compared to how much gas does it take to grow a tomato in Eastern Washington versus grow it in California or Mexico and transport it here. And unfortunately, sometimes the answer is, well, it's not worth it to grow that particular crop here. But with cannabis, it's, in any given market, it's still worth enough that you can actually push. I mean, we're looking at getting, 110, 120 grams a square foot is our, grams per square foot is our metric we try to refer to here for the most. And obviously there's, important ones to other people, but rewind it 10 to 15 years. And that was an incredible amount of biomass to be getting out of one of these, indoor grow systems. And I'm sure we've got, plenty of growers out there say, oh, I was nailing 4 pounds of light 20 years ago. Sure. I'm sure those existed. But on average, hitting those numbers was very, very difficult. And most growers didn't have access to a facility that would let them do that. This level of HVAC control, this level of CO2 supplementation control, sealed rooms, like the whole 9 yards. And I know for my journey, just getting into cannabis, it was quite surprising, from HVAC requirements to how much fertilizer are we dumping onto these plants to, it's a whole different approach. And like I said, unfortunately, the directions we're just getting to the point where you can get good, I don't want to say good advice, good directions, good written literature that tells you, hey, case example, here's what happened. Here's, some useful information to actually help you, because up until very recently, everything was just under spec.
Yeah. Yeah. That's honestly one of the things I love about the industry is it's kind of the Wild West. As you said, it's getting more defined, but as someone who's kind of new in this industry, it's kind of exciting for me to be on the forefront of acquiring that knowledge and seeing these trends and whatnot. And it's really cool. Like, cause other work that I've done is, with like office buildings or I don't know, universities or whatever. And the impact of HVAC, they pay whatever for their energy bill, and somebody might get a little cold and they got to put on a sweater or whatever. But in this space, it's one of the main ingredients in success. It's the foundation of success is your ability to control your environments. And then on top of that, it's very complicated too. So I just personally, I think it's super fun. And then you have the connection to an actual living, breathing, thing and how well it's doing. So it's like, that's one of the things that I love about this space. And what's cool about cannabis, because like you said, the price per pound is such that it allows for an investment in this type of research and whatnot. And as at least at this point, the energy cost is still high, but it's not like not like tomatoes grown in the Netherlands or whatever, where where I think like during the Russia-Ukraine war, when natural gas started to go up a bunch, like you said, their whole business model was collapsed. So it's a really cool space to be in.
I had a couple of things here. Seth got me all distracted thinking about why the other greenhouses had some different ventilation, and a lot of it was because of the graphs that I was looking at and the influence I had before we made the purchases on those greenhouses. And
big dead bands, real big ones.
Yeah. So in the first greenhouses, all we had were gable vents. right? And gable vents, if you're familiar with greenhouses
and
or
no ridge
audience.
vents either.
Yeah,
For
well, no
greenhouse
ridge
growers out
vents
there, yeah,
for
you'll love that statement.
in and out the long way. But obviously they open fairly slowly and they close fairly slowly, and we're letting in lots of volume. And so we either have to operate on very, very small adjustments, or we get big swings, right? And so, what I was seeing was obviously this red line, and we were operating on our big pad vents. And so the second greenhouses, we threw in some actuated, just some quick actuation.
You got a third line to show humidity too?
No, I was
on those greenhouses, that was pretty huge.
But so what we did was we threw in some, I think they were 4x4, just quick open vents, right? So I could either be on or off, right? And those allowed me to make, really quick adjustments, right? And so when we think about how much overshoot, and with the equipment you're working on, you can probably implement PIDs for some of this types of stuff. I didn't have that option with our controllers at the time, and so it was like, well, if I just need small micro adjustments, we can use those quick action vents, and I can operate them, 10, 15 times a minute, really, if I need to,
and do it reliably.
Do it reliably.
Like with existing non-specialized equipment, like that was a small upgrade that had a huge impact.
Yeah.
And so, when we think about, all right, how do you take as much data as you can and distill it into improvements like that? You're doing exactly what you said. You need to grab as much of it as you can, and then start to identify which ones are related, right? And fortunately, in the upgraded greenhouses, I ended up putting sensors up towards the front of the greenhouse and towards the middle of the greenhouse. I was also implementing those substrate sensors. And when we start to identify which ones are related, we can start to isolate that, like you were talking about. And that's really what gives us the insight on to which of these changes should we invest on, right? Is it worth it?
Yeah.
Is overshooting by 5 degrees, detrimental to our optimal transpiration rates? And like Seth said, obviously, when we compound that with humidity, when we're working in greenhouses specifically, things start to get more than humans are really good at analyzing. And I think
exactly.
Well, and the reality is, for a lot of these systems, we're talking about these dead bands, these green lines, and this first green line Jason drew, that's where efficiency lies. And when we start to go out of these ranges, cumulatively over the run, we're just stacking up more and more time spent in an inefficient condition. And that's why you see, on these macro level studies where you're looking at what kind of environmental conditions promoted this or that. A lot of times I'll go back and look and say, hey, we got to throw out 50% of that data. Like, why? Well, you guys couldn't keep it inside of a 10-degree dead band. Like, okay,
exactly.
Well, there's another variable, guys. Like, we got to chip away at this. And it's
totally. That's
it's an endless journey.
Everything I studied was imperfect operation, basically, like a good couple of days and bad. So it's like, makes it very challenging to derive very solid correlations.
That real world data is important though, because that tells you what can actually be done there. And you have so many case examples to do it, right? Like if you can collect that data without Willy rolling out with a clipboard and a camera, on site every day.
Yeah.
Now you can actually spend your time, working on that and making meaningful
one of the
impacts.
Cool things too, right? Is like now with the type of crop registration that you've got with the Roy, you're able to overlay all these graphs on one screen, see exactly these types of patterns forming as you're noticing these things happen in real time. And the cool thing is that knowledge now exists in you. And when someone asks you, hey, can you look at my graphs and tell me, where my efficiency pitfalls are? You're going to have a good baseline knowledge of what that looks like in the patterning of those graphs, and as well how to overlay data in a way that makes it easy to see all of those factors. Yeah,
I totally agree. I think the ability to, because, we're getting to the age where a lot of analysis and things are done by machines, but I think it's very important to visualize data in such a way that a human can intuitively understand what's going on. Because at the end of the day, a human, even if you are doing AI or machine learning, a human's got to set up what it is that they're looking at. So the ability to visualize your data is sort of the first step, I would think, in that process, is because you need to see the data, and you see a couple sample days and you're like, oh, I see this happening. So now let's, put some algorithm in there, whatever, that looks at the whole data set and looks for these patterns specifically. And once you can vet it out over your entire data set, then you're on to something. But I just think there's so much power in properly visualizing data in a way that a human can intuitively understand. And I would say that outside of like just the practical utility of it, there's something satisfying about it. From just like a humanity standpoint, I feel like as humans, we're made to recognize patterns. So when you can display data in such a way that allows you to see those patterns, it's like it taps into something
Graphs,
innately
not spreadsheets.
human. Yeah. Huh?
I said graphs, not spreadsheets.
Exactly.
I love using that example. Like
taking that red line to that green line. It's one of the most exciting things to see happen in real time. You know what I mean?
Exactly.
You quantifiably feel how satisfied you are with actually being able to create the result you were after, and
totally
on board with it.
And even more satisfying, especially in the cannabis space, is these lines represent something
little negative sign next to that one there.
Is very important for your business. And as we move from one color line to the other, it also has the corresponding financial gains.
Yep.
Exactly. Yeah. It's very satisfying. I come from a world of consulting, and one of the things I didn't love about it is that, we'd be in either really beginning or at an existing project or whatever, and we'd write these big studies and tell them what they should do, but we never had fee to go see what actually happened. And that's what I love about this space, is that because of like the iterative repeatability of these facilities, you get to see things happen. You get to see the results, like as you were mentioning, you get to see the results of what you did. And I don't know, for me personally, there's nothing more satisfying than that.
I think that's awesome to say, man. I would say we are all after the same thing there, and probably all of us get the same amount of excitement getting that red line to go head towards the green one, whether it's our grow or someone that we're consulting or just helping with. One question I wanted to toss at you before I forget to do it. As a result of the studies you put in, what do you think we're going to be seeing as far as regulations coming down the pipe at our industry that we can, look at in terms of managing our HVAC systems better?
Yeah, I would say it's going to be maybe twofold. That I don't know if I would get in trouble. I don't think. I'll just speak from what I would see personally.
Keep it vague.
That I would say, I would say integrated systems are probably going to be incentivized more, and there's going to be more of an effort to sort of demonstrate why. And of course, there's probably going to be like a minimum size. Like if you have a very small grower, they're not going to force you to buy, some super expensive large piece of equipment. But there will be more of a push towards having these integrated systems, and then secondly, having the controls that are set up to properly monitor and control these spaces. And I don't know if there's really a precedent in code for this, but I would say, besides just monitoring the temperature and humidity of your space, like HVAC units typically do, the HVAC system should be controlled to the same sort of central brain as your irrigation, as your Arroyo, as your CO2, as your lighting, so that you get this understanding of the interaction of everything, and because part of code's purpose is to despite what people may think, the overarching goal is to help consumers out. Like that's the whole, to protect consumers. And in this instance, I believe at this point that assuming it's properly designed and implemented, you get a better bang for your buck spending the money on an integrated system that's capable of operating at a wide range of conditions, versus a decoupled system that might be substantially cheaper at first. But if you look at it over 5 years, you're probably better off with the thing that can keep more stable environments. So that's kind of the intent of code. And I'm speaking a little cagily because there's probably going to be some controversy just, around standalones and stuff. But as I said, I think there's always going to be a need for them. It's just it's not really an opinion. It's like the science and the physics of everything show that you need a system that's capable of modulating over a wide range of conditions to serve a room, which is creating a wide variety of conditions. So I would say that that's probably where code, and we're talking like 2028 or something. So yeah.
So I think Willy's still going. No, are you still going?
No. Yeah, that's it. Yeah.
I was gonna say, one of the things that I really enjoy about helping people that have consolidated controls is the fact that they can start doing preventative or predictive type of controls, where typically when we're standalone, one piece of equipment doesn't know what may happen in the future. So anything that it's doing is reactive. And when we're on a reactive basis, we're almost always going to see a larger offset, right? Because we don't have the opportunity to make adjustments before that happens. When we think about, let's say we have to irrigate to 20% runoff one day when we're used to doing 5% runoff. Well, we may actually push our humidity down just slightly before we do that, because we're going to see that increased water load in the room, right? It can't happen when we're on discrete equipment. That equipment only sees the increase in load and then responds to it. It doesn't have the ability to, so we could be plus or minus 5% humidity, or we could be, only plus 10%.
In your example, like let's say adding 20% water to that room at a specific time of the day, it's quite impactful with humidity. And we can easily make the choice whether to, like you said, ramp that up, ramp it down. Simple decisions like how close to lights off am I going to water? How does that watering impact humidity? And what's my control capability for it? Like we have clients that have overcapacity systems. They'll run something like a Hugo, a 6x6x6, and push massive amounts of runoff all day. It's not an issue. Other clients, hey, never water more than 2 hours after lights off. Why? Well, your dehus aren't going to keep up, dude. Your lights are going to shut off. You're going to have a massive humidity spike. Like, you're going to spend so many hours trying to dial in those set points when the cause of that was just your decision to irrigate a little bit too late in the day. And back to what Jason said, if you have a consolidated system, as soon as you can start having things work in concert, you save yourself so many error points. Like if you've got to go do set point adjustments every single day before lights off, what is that? 60, 65 chances to mess it up, provided like, your life allows you to like be there till that exact time every day, make those switches at lights off. Like, it's kind of a no brainer when you talk about like expanding that to like, okay, how do we scale this and make it operational? But also, from a regulatory standpoint, I really wonder when we're going to start looking at, responsible business metrics and saying, hey, yes, you can put up this facility, but unless you have a business plan to produce for under a certain price per pound, let's say, or whatever metric you're going to put on it, is that even a responsible choice to put in our community? And not like pushing it toward total socialization, but in community, city, county planning, like everything like that's taken into account. We don't necessarily want to be putting in a bunch of businesses that aren't going to make it. Right where we live here, we're right on a state border. There's certain businesses you should do in Washington and certain ones you should do in Idaho for various different reasons. But you'd be silly to get it wrong when you go to build your building,
Right. Totally. Yeah. And it goes towards, the idea of regulation is to protect people from themselves sometimes. So yeah, totally. Jason, I love that idea of predictive controls and also sort of like intelligent, preventative maintenance, I think is the word they're using. The having everything integrated, consolidated is the first step in being able to apply procedures such as that. And I think that's kind of like the state of the art, cutting edge things that will start to be happening probably more and more, hopefully in the coming years. And, with the preventative maintenance, you might be able to have intelligence in the system to like, oh, you see your compressor cycling a certain way. It's giving off some sort of signature. That usually indicates it's probably going to fail within the next 2 weeks. And so you could save yourself a pretty calamitous event by taking action before. And then the predictive controls, these spaces are built for that because they're complicated, but they're very regimented. So it's like, what's going to happen on grow cycle day 6 versus grow cycle day 25, right? You know what's going to happen. So theoretically, you could have your HVAC system ramp up before it starts to show up on the thermostat. I think those are two really exciting possibilities.
Oh yeah, and just utilizing technology. I'm glad you brought up, being able to just look at power consumption or feed to a device and see that it's going to fail. Like, hey, this is producing right back to pattern recognition. This is a weird pattern. There's kind of this gap I find a lot of growers have because you're operating a farm, but it's also an industrial factory on a certain level. You've got a lot of equipment to operate. So there's certain things like ground resistance checks and stuff like that are, more popular or not more popular, required at certain bigger production facilities if you're in a more industrial setting that aren't necessarily being required by regulation in cannabis because of where it falls between ag and industrial production. But there's a lot of small wins in just utilizing some of this electronic monitoring equipment to identify that, there. If I was going to go do ground checks on a facility, that's, anywhere from 10 to 15 minutes per motor in your facility. Okay. Start counting up electric motors in your facility. Yeah. What if you can do that just by pulling up a screen on your computer and see if anything's like behaving weirdly? That's such a huge win. And it's
totally
technologically that's tiny.
Yeah, it just helps with troubleshooting so much. Sorry, go ahead.
I was just going to say, I kind of want to keep the conversation going as long as possible, but I feel obliged to wrap us up before too long here so we don't run over time. I did want to throw one quick question out from one of our guests live today. Iron Armor, one of our regulars, said, great episode, guys. Quick question. What are some systems that would integrate your AC, dehum, and humidifier together?
I think like Microclimates does it. It's something that I'm hoping to offer here pretty soon. I don't know if I'm allowed to like self-promote or something, but
yeah, you are.
That's kind of what
Absolutely,
okay.
Hit Willy up.
Stober Engineering.
Yeah. So that's exactly what I'm working on is I'm working at the facility in Sacramento to kind of do something like that. So me potentially, I know Microclimates, I think, does it already. And there's probably a couple other companies that do it. And then also just individuals who are integrators who could there's this guy that I work with, Jeff Landreth. He could do that now. He's really good. So yeah, that would be he's just like kind of a unique engineer who knows how to do that on any type of system. So yeah, I would say there's a couple companies out there that do it. And then there's individuals, one that I know of that can already do it. And then hopefully me here pretty soon.
Well, I think that's an important thing to highlight, Willy, is that, when we're talking about just this concept of, consolidated holistic control of the environment, irrigation, everything that's going into controlling everything we can about how these plants grow, you're talking about a pretty wide range of industries and manufacturers and vendors that all, they produce technology that crosses over into other industries. So it's kind of an unreasonable expectation to think that one particular company is going to grab and own this. And much like other sectors of manufacturing and farming and really any industrial activity, the specialization is necessary. Yes, it's 2025. We live in a digital world. It's awesome.
Mm-hmm.
There's still a lot of connection points that have to be done manually. And when you start to quantify the amount of time you spend battling like a standalone decoupled system with 5 other standalone systems in your facility versus just paying someone that actually knows how to hit the ground running and make it work correctly from the beginning, or is able to walk you through and solve those problems for you, is huge. If you hit the ground running and you have a system that by specs should be able to put out 95 plus grams a square foot and you're hitting 30 because you can't get the controls down. Like, man, to me, like, I know everyone's got a different checkbook, different bank account, but like like that seems pretty obvious, man. Just get the expertise. There's nothing wrong with not having the pride. Like, Jason here knows bounds more than me. There's just so much more on system integrations and stuff like that. But it's because he spent time doing it a lot. There's value in that. Just like yourself. Like, we could talk all day about environment. Do we need to talk about like plant chemistry? No, that's not important to this conversation. And you spend so much more time specializing on how to make these systems work efficiently that there's no way I could catch up to what you're doing without like changing careers. And that's right. That's fine. Everyone has that place in their life. It's important to just recognize where you bring the most value and where you need to bring some help in.
We all bring different skills to the table, right?
Yep.
Yeah, I 100% agree. I do think it's that application, that work is maybe better suited for talented individuals at this point, because each facility is so kind of custom and one-off that these companies that try to appeal to everyone might not, it becomes harder. And maybe microclimate.
One size fits all doesn't truly fit all, right?
No.
Exactly. So,
well, guys, I think it's clear we could probably go on for another couple of hours here, but I do have to end us out for the day. Guys, thank you so much for an awesome conversation. Willie, thank you for coming on today. Everyone that's tuned in today, if you get a chance, check out Willie's paper. Willie, you said you're gonna go there for a little sign off.
Let's get the plug.
Go where are you? You cut it.
Oh, you just started talking. I wanted to lend you the floor for a second there.
Chris is dropping a link into the chat here. So go ahead and describe it, Willie. Plug what we're linking to.
Oh yeah. So this is the paper that I spoke of that I worked on for the last 2 years. It's pretty dense. So if you have any questions, feel free to reach out to me, but there's some good stuff in there. It covers the whole gamut of growing and thermal loads and energy consumption and all the interesting stuff we found. So it's publicly available. I sent you the link's about to be sent. So
awesome. Thanks, Willie.
Check it out, guys. You're going to be hard pressed to get, I think, better, more current information on what the research is showing in some of these controlled environments and what the best ways are to actually try to control them.
Yeah,
absolutely. Cool. Seth, Jason, thank you. Willie, thank you. Guys, thank our producer, Chris, and everyone out there watching today. Thank you guys for tuning in to what has been a really fun episode to just sit here and talk with industry expert Willy Stober. Cool. Do you guys ever end up looking down the rabbit hole of these consolidated control systems? Make sure to look Willie up here. He's going to be the industry authority that we know. Guys, thanks for tuning in to episode 134. We'll see you guys next week. Remember to give us a like, and we'll make sure to get back to our normally scheduled question and answer this next week when we log back in. Thanks you guys for another great episode.